The following video will be about firearms. It'll be specifically about 410 shotguns. It won't be about making them. It will be about how to extend the life or reloadability and reusability of your firearm, keeping it clean, that sort of thing, and also ammunition. Warning. Unless things are really, really bad, don't do any of these things unless you get advice from a person in person, take some classes, and read every manual and warning label until you've memorized them and can write them out. I'm not kidding. We're going to be dealing with black powder, gunpowder, and smokeless powder being discussed. We're going to be talking about primers, whether they're pistol, rifle, or shotgun primers. And we're going to be talking about the components besides that, for instance, projectiles or projectile for shot or bullets, and the cartridge, metallic or paper and plastic. Paper or plastic? Yes. Let's talk about the price tags for reloadable or replacement cartridges if you're going to make your own, literally roll your own, or reloading. The three components that you add to the cartridge is the part that connects these, is the primer, propellant, and projectile or projectiles, shot. The cased ammunition rule about this is that you have a primer that's stuck in the back of the cartridge, then the base in it is filled with propellant, and then if it's a bullet that you're going to put in for a small cartridge like a 22 or 25 ACP or whatever. Yes, there are 22 center fire cartridges, by the way. Look them up. But let's say you're doing 25 ACP, you then put the bullet into it and either crimp it or just press it in or whatever, and that's your cartridge. And after it's fired, all that's left is the empty casing and usually the primer and nothing else. In the case of shotgun shells, it's almost identical, except you can put in other things, such as a gas-tight seal or gas seal that goes over the propellant, which can be smokeless powder or black powder. It's called an over-powder wad or card, nitro card, etc. And then you can put shot on top of that, or you can also put in something called a shot cup to contain it for as long as it's in the barrel to reduce wear on the barrel, make the patterns more consistent, whatever. And on top of that, you put an overshot card and or a crimp over the cartridge by either crimping the cartridge shut, like you could with a 25 ACP. You can squeeze the top of it off just a bit to make a better seal of the bullet. Or you can leave it open and push in an overshot card on it and seal it with glue or something. Sometimes they even just have an oversized version of that crammed in, and that's good. And there's a dozen other things you can put in there for cartridges. Now, a bit of a safety warning. Pistol cartridges and rifle cartridges are usually, but not always, considered a higher pressure and higher danger level from failures than shot shells. The reason for that is shot shells, and the SAMI specs bear this out, is around 10,000 to 13,000 pounds per square inch, which is extreme, but pistol and rifle cartridges easily exceed these things depending on the types you're looking at. By and large, shotguns and shotgun ammunition have a lot more slop factor for being safe. They're a little less dangerous to diddle with. Again, still read all the manuals. You can read the information on the propellant package, whether it be smokeless powder or black powder. You can read the information that comes with the primers. You can read the information that comes with the cartridges. Even the birdshot, buckshot, or slugs sometimes come with little pamphlets on this. There's no excuse for not reading the instructions. But let's go on. We're going to be dealing in this video with making these things last as long as possible. That includes reloading shot or slugs and remaking them. That's a whole other video, but that involves melting lead or non-toxic materials. Remaking primers is beyond the scope of the video, but you can watch videos for doing that. And also making new propellant, because the propellant is expended. 410 shotgun shells, as an example, 2.5-inch Magtech full brass cartridges. If you're not aware of it, shotgun shells are normally made with a metal base that has a rim, a small amount of metal sidewall, which is called the brass or high or low brass, etc., and then another tube that's usually pressed into it that is the part that's actually holding the majority of the content. The brass usually goes up to the height of what would be expected for propellant primarily. Mostly because in the old days, if they were made out of something softer than metal, they would get pinholes because the propellant is burning. So that was a way of making sure it didn't burn through the sides and cause a problem. And the rest of the shell, besides that metal base, can be made out of paper, plastic, or full metal. The Magtech shells that are 2.5 inches long, all metal, which usually have a pistol primer rather than one that you would find in a shotgun, which would be a 209 primer type, go from anywhere from $1.25 to $1.36 or $1.40 each. They used to be cheaper for 410 shells. Now you can also repurpose other shells. There are other cartridges like 45 Colt and other cartridges that have a rim and a base that are very similar or identical in one case here to the 410 shotgun shell. There's also an equivalent for doing this with 12 gauge, but we're not doing that in this video. Now, you can get emptied brass that's had the primers popped out and it's been chemically cleaned and it's ready to go for $1.16 for each cartridge, and it's a full brass cartridge 3 inches long that could work. It's just that it's made for a rifle bullet. It's like a .30 caliber neck down, and it really is just a 410 shotgun cartridge, really, neck down. It really does look like they did that. The numbers are so close that you could probably just get away with using it as is by filling it creatively, and on the first firing, it'll blow open to be the right diameter anyway. Considered a pre-crimped or pseudo-crimped shotgun cartridge. And yes, you do need to make sure they're annealed by heating up the end and getting it to where it's softened so it won't split. Now, there's another option for this if you want to repair a shell that's been damaged. Now, remember, most of these cartridges, 410, 12 gauge, it doesn't matter, if they have plastic straight walls, don't really wear out that easily unless you abuse the hell out of them or you crimp them. The types of crimp or seal for the top to keep the stuff from falling out, or also maintaining pressure by holding it back just for a couple of milliseconds during the firing process, that top being sealed up can be done in many ways. One of them is to just glue a card in it or jam fit one in to where it holds it back enough to where it doesn't fall out, all the way up to crimping the sides in just a little bit to where it curls in just a tiny amount of it, like 1/8 of an inch or less, to where it holds it in almost looking like the top of a can, like a soda can, to folding over the edges in a pattern that's sometimes called a star that holds it shut. That last one wastes a lot of the length. It also wears it out a little bit faster depending on how it's done, sometimes less. The roll crimp wears it out a tiny amount, and you may have to trim it off, but you can keep using the cartridge. But not rolling at all makes it to where it doesn't seem to wear out at all. And again, they make full metal ones here for $1.16 all the way up to $1.36. But what about repairing the cartridge? Now we're at the point you're not even remaking or reloading. You're just doing something that's probably stupid, but let's cover this quickly. Can you replace that plastic tubing and the rest of the components in the cartridge and reuse it when you're basically just stuck with the metal base of it? And the answer is yes. This was done in the 1800s, and the method is the following. You have to get everything out of the base of it. These days you'd heat it up on an upside down clothes iron or something like that, or just heat it up in really, really hot or maybe boiling water, and then pull out all the plastic stuff at the base, put it in a replacement tube. They do exist, just have to look around for them. You have to look up what their outer diameter is and hope that it'll work. And then you put in a cork in the bottom that fills it in and presses that tightly. It doesn't need much work this way, by the way. And drill a hole through it so that when you put the primer in, the exhaust gases from the primer can go in and hit the propellant. One of the caveats is that when you do that, you have to make sure that piece of plastic tubing is slightly curved in, literally crimped, only in the base. And the cork or plug is really called a base wad. Coincidentally, you can buy wads, gas seal wads that are slightly oversized, that you can just drill a hole in and it'll become the base wad. That's actually something that used to be sold that way. There is a couple of companies that sell the base wads to do exactly this, to make them. Normally what's done is those pieces are put together just like I explained, and then the base is crimped to form that little rim and squeezed around it to tighten it. But this does have the ability to work mostly. There is a likelihood here of all the plastic or cardboard or paper you're putting in physically being thrown out of the barrel and jamming up things and maybe causing a bore obstruction. Next, can you make your own metal casings? Well, yes. For 410 only, it's a 15/30 seconds or 0.469 outer diameter yellow brass alloy 260 piece of tubing. It's available lots of places. Now this is where it gets somewhat attractive and kind of dangerous. Again, you still have to create a base wad. You could also make the base wad out of metal to make them ridiculously durable. It's 0.3 inches thick if you're not aware, but it's almost like a stack of washers. And this brass tube, if you had a real brass base, you could solder it to it by using tinning flux, putting all the parts together using the tinning flux also as a lubricant to get all the parts in, and then heating it up with, putting it on a low temperature hot plate would melt the solder, and it would be bound to it like super glue. Now, what's the cost for this? Now, of course, we just discussed the cost, anywhere from $1.16 to $1.40 to get a shell one time that you can reload a massive amount of time. Or just go find cast-off cartridges no one wanted to reload and just reload those. They're free. That would be a lot better. And or what would the cost be to make, let's say, almost 2.5 inch long shells to 3 inch shells? 54 cents to 80 cents to do a 2.5 inch shell, almost. And for 3 inch shells, it would be $1 all the way down to 67 cents. And that's actually cheaper than getting the plastic and doing it as a shell. And it would be brass. And even if it wasn't a brass base you were dismantling and cleaning up, if you chemically strip it and then line it with the solder paste material that's called tinning flux, it would probably work just fine. Much better even maybe than just putting something into it to kind of quasi-crimp it. What's the normal shell inner diameter and wad diameters, and what punch would you use to make your own wads and such is something to look up on another channel, but you end up going from, let's say, 13/30 seconds to 7/16, and that's a dynamic change of 0.406 inches to 0.437 inches in just one incrementation. This is the reason that sometimes you need to just go out and buy the actual wads that are punched exactly for doing these reloads. The wad diameters that I saw for sale and other people had measured to test went anywhere from 0.383 inches to 0.5 inches. Basically 38 caliber to 50 caliber are used commonly depending on the make, model, and brand and year of the shotgun shells. So how large is the inside of that tube, the brass one? It's 0.441 inches inner diameter. It's one of many sizes that isn't listed as being a proper wad diameter, but it is a base wad diameter that's listed on 2 Chinese websites. Now, I want to point out the cartridge. The Bottleneck cartridge is a 9.3 millimeter by 74 millimeter rimmed cartridge. That's all it's ever called. It's a bottlenecked case, and it's just under 3 inches long. I also want to point out the MagTac shells at 2.5 inches are actually short of that, and would give you almost the same result as using the metal tubes. And again, if you buy the brass ones and don't ever crimp them, you buy them once and just reload them. The cost of reloading I've done in another video, but it's really, really cheap compared to this. But the cheapest of all is go find a bunch of shells someone's already fired and just reuse them without ever crimping them, and they may last a ridiculously long period of time without you looking up how to do your own or roll your own brass shells, fire form them, or buy them from MagTac. I'm sorry, but 1 cent each bulk rate used cartridges are available. I can't see a way that's... Buy the used cartridges or go find them at a shooting range and reload them. You'll be infinitely safer and it'll be infinitely cheaper. The main cost at that point is the shot, the propellant, or the bullets and propellant, and the primers. You can remake primers, you can remake the shot and slugs, but I really recommend you start with at least not remaking the cartridges. Please don't remake the primers either. That's actually very, very dangerous, depending on how you do it or not. Thanks for watching. Have a good day. Good luck with that. This has been mostly a public service announcement for those of you out there who are dealing with the current situation we're not supposed to say on YouTube videos because we get flagged improperly. Bye.